We are solving question number 27 of GATE 2021 chemical engineering paper. This question is related to fluid mechanics. Consider a fluid confined between two horizontal parallel plates subjected to shear flow. In the first experiment, the plates are separated by a distance of 1 mm. It is found that a shear stress of 2 Newton per meter square has to be applied to keep the top plate moving with a velocity of 2 meter per second while the other plate is fixed. In the second experiment, the plates are separated by a distance of 0.25 mm, and it is found that a shear stress of 3 Newton per meter square has to be applied to keep the top plate moving with a velocity of 1 meter per second while the other plate is fixed. In the range of shear rates studied, the rheological character of the fluid is, which of the following option is the correct one? Now, over here we can see that we have been given two horizontal parallel plates. Let's say this is our top plate and this is the bottom plate. So in the first experiment, the plates are separated by a distance of 1 mm. So this is the first experiment, and this distance is 1 mm. It is found that the shear stress of 2 Newton per meter square has to be applied to keep the top plate moving. So let's say tau we have been given as 2 Newton per meter square. The top plate is moving, whereas the other plate, that's the bottom plate, is fixed. So let's just consider this as fixed. And this plate is moving in, let's say, x direction. This is y direction. The velocity is 2 meter per second. Now in the second experiment, we have been given the plates are now separated by a distance of 0.25 mm. Now the distance is 0.25 mm. Shear stress applied is 3 Newton per meter square with a velocity is equal to 1 meter per second, while the other plate is fixed. Now we have to study the rheological character of the fluid. So that we can study using the power law equation that states that tau is equal to mu naught d velocity is in x direction, that is dvx dy raised to n minus 1 dvx on dy. So based on the value of n, we can comment on the rheological character of the fluid. So basically, if n is greater than 1, that implies the fluid is dilatant fluid. If n is less than 1, that implies it is a pseudoplastic fluid. If n is equal to 1, then we can say it is a Newtonian fluid. And if there is any other form of this tau, then it won't lie in this three category. So to find the rheological character, we need to find the value of n. So for that, we will be using the provided information. So first we have been given the change in the velocity that is occurring. So initially the velocity was 0, then we were applying the shear stress of 2 Newton per meter square, and then the velocity become 2 meter per second. So from that we can calculate this strain rate, or you can say this value, or the velocity gradient, and then replace it in this equation with the desired data that has been provided, and then find the value of either mu naught or n. So let's do that. So first we need to find the value of this dvx by dy. So let's just consider this dy is very less, so we can write this derivative as delta v upon delta y. So that is basically we can write v2 minus v1 upon delta y is basically this distance. So you can just write it as y. So we will be using this. Now for case 2, For both the cases, basically, we can write this tau1 is equal to, let's just club both of this, and we can write this as mu naught dvx by dy raised to n. Now, value of mu we don't know. And dvx by dy, for case 1, we can write the velocity was 2 meters per second. That is still 2 upon 1 mm is 10 raised to minus 3 meter raised to n, and the shear stress applied was 2 Newton per meter square. Similarly, for case 2, we can write this as mu naught. The velocity is 1 meter per second. For now, distance becomes 0.25 mm. That is 0.25 into 10 raised to minus 3 raised to n is equal to shear stress is 3 Newton per meter square. Now we can take the ratio of 1 and 2. So we will be having tau2 upon tau1 is equal to 3 upon 2 is equal to 1.5. This will become, so both of these terms will get cancelled out, and we will be having 2 into 0.25, that is 0.5. That will become 1 upon 0.5 raised to n is equal to 2 raised to n. So from this we can take log and find the value of n, and it will become n is equal to 0.584. So since the value of n is less than 1, we can write that the fluid is pseudoplastic. So this implies that the rheological character of the fluid is pseudoplastic. And from the given option, we can select option B as the correct one.